Hi everyone, for today's lesson, we are going to learn how to simplify numerical radical expressions. To get started for today, we're going to do the following warm-up, where I would like you to please evaluate each without a calculator, write as prime numbers to help evaluate. So what I would like you to please do is pause the video, answer A, B, and C. When you have an answer, please restart the video and we will see how well you did. All right, so let's go ahead and look at the very first one. Letter A, we have 343. And what I know about 343 is that that is equal to 7 to the third power. And we're raising this to the 5/3 power. So I'm going to eliminate the 3's because the multiplication of 3 is equal to the division of 3. And now I'm left with 7 to the 5th power. And if you did need a calculator, that is okay. 7 to the 5th power is 16,807. Now, I am not going to be this mean on a test or quiz where I give you something that has such a big answer. It'll be something that will be a lot smaller than this. So I'm just putting that out there. The whole point of this is I want to make sure that you know what you're doing. If you simply left your answer as 7 to the 5th because that's a really big number, I'm okay with that as well. Let's go ahead and look at letter B. In this problem, notice that we have a fraction. And what I know about 27 is that it's really 3 to the 3rd power. So what I'm going to do is I'm going to bring that 3 to the 3rd power up so that I end up with 3 to the negative 3rd power is being raised to the negative 2/3 power. So now the multiplication of 3 eliminates the division of 3, and a negative times a negative is going to give me a positive 3 squared. So my answer is 9. And finally, 625. If you worked with 25, that's perfectly fine. But I'm going to work with 5 to the 4th power because the smaller base tends to be the easier base to work with. So I have 5 to the 4th raised to the 3 to the 4th. The 4's are going to cancel away, leaving me with 5 to the 3rd power, and that is 125. So hopefully you found this warm-up to be relatively easy, but if you struggled with it, please make sure that you contact me as soon as possible. Our learning targets for today's lesson is for you to be able to say, I can simplify numerical radical expressions, and I can add and subtract whether I have like or unlike numerical radical expressions as well. So we're going to be working with like as well as unlike. So let's get started on this property of multiplying and dividing radicals. This will help us when it comes to simplifying. This is a property that we have discussed before, so I just want to make sure that I talk to you guys about it again. And that is if you are taking the nth root, whether it's square root, cube root, whatever the root is, and you have multiplication inside, you are allowed to take the nth root of each piece, the nth root of A times the nth root of B. Likewise, if you have a product, you can also make this the nth root of A times B and put them together. So both ways will get you being the exact same thing, and you're allowed to multiply. This is only true if you are multiplying radicals. If you're dividing radicals and you're taking the nth root of a fraction, you can't leave your answer like this. So we would take the nth root of A and divide it by the nth root of B. Likewise, if you're taking the nth root of A over the nth root of B and you can't simplify it anymore, sometimes it's helpful just to take the nth root of A over B. Please remember that you cannot have a root in your bottom for a final answer, so we want to make sure that we truly simplify it completely. Please note that simplest form, when they ask you to simplify, simplest form means that a radical with an index of n is in simplest form if the radicand, which is what is underneath the radical, has no perfect nth powers as factors, and any denominators has been rationalized. So there might be a little bit of rationalizing the denominator. I think most of the problems that I give you, we don't have to do that. So let's go ahead and look at letter A. Please note that for a lot of these problems, there's going to be multiple ways in terms of solving them. So you just want to go with whatever way you see, and there's nothing wrong with that. So here's letter A. What I see here is the cube root of 125 and times the cube root of 8. And I notice that the cube root of 125 is really 5 to the third power. And 8 is really 2 to the third power. So the cube and the cube root, they cancel away, leaving me with 5 times the cube root, and the cube cancel away, 5 times 2, and 5 times 2 is 10. That's one way to view this problem. Another way you could view this problem is you could multiply 125 times 8. And 125 times 8, that's 1,000. And the cube root of 1,000 is 10. That's another way to view this problem. So there's multiple ways that you can do these types of problems. Do not feel isolated into one approach or another approach. Just do what you see. For letter B, what I see in this problem is I see that we have the cube root of 96 divided by the cube root of 3. Now 3 and 96, they are related. So what I can do is I can rewrite this as the cube root of 1 fraction of 96 divided by 3. 96 divided by 3, well, that's 32. So this is the cube root of 32. So now what I want to do when it comes to 32 is I have to look at the root that I'm taking. I'm taking the cube root. So I have to ask myself, does there exist a perfect cube factor? So what does that mean? If I were to go back to my list of perfect cubes that I had on day 1, obviously 1 will always work with everything, but can 8 go into 32? Is that a factor of it? Yes. So what I'm going to do is I'm going to rewrite this problem as the cube root of 8 times 4. The cube root of 8, that is equal to 2. So really I'm taking like the cube root of 8 times the cube root of 4, and that is going to be equal to 2. The cube root of 8 is 2. Now 4 is a perfect square, but it's not a perfect cube, and it doesn't have any perfect cube factors. So we leave our answer as simply the cube root of 4. So 2 times the cube root of 4. Let's go ahead and look at letter C. Letter C, I see that I have 245 divided by 5. And 245 divided by 5, if you put that into a calculator, that is 49. And the square root of 49 is 7. So that is our answer. Let's go ahead and look at letter D. For letter D, I have 432. So this is a perfect cube. And I want to look at these, and I'm looking at 432, and I don't know very much about 432. It's a pretty big number. So what I do notice is that it's divisible by 2. So I'm going to take the number 432, and I'm going to divide it by 2. So I know that this is probably going to be, well, the 32 divided by 2 is 16, and 400 divided by 2, that's 200, so this is 216. Okay, I know something about 216. That's 6 cubed. That's a perfect cube. So I'm going to rewrite this as the cube root of 216 times 2, and I like to put my perfects in front. And if it helps you, break it apart into the cube root of 216 times the cube root of 2, so that you'll end up with 6 times the cube root of 2. Now this extra step is an extra step. If you want, you can just say, oh, I know that the cube root of 216 is 6. Leftovers is going to be a 2 inside. Let's go ahead and look at letter E. For letter E, I have 104. I don't know very much about 104, but what I do see is that 104, well, that's divisible by 2. So I'm going to write 104, and I'm going to divide it by 2. And that is going to be equal to 52. Okay, I don't see any perfects yet, so I know 52 is even, so that's going to be 2 times 26. I still don't see any perfects, so I do know that it's divisible by 2. And so this is 2 times 13. Okay, so there's nothing more for me to break down, but what I do see is that this is 2 times 2 times 2 times 13. This is 2 to the third power times 13 is 104. So I'm going to write that down. The cube root of 2 to the third power times 13. And if you were using a calculator, maybe you would try 8 to see if it worked. So now I know that the cube root of 2 cubed, that's going to be 2. My leftovers is going to be the cube root of 13, and that's my answer. All right, so I'm going to make letter F, letter G, and letter H solo problems. So if you wouldn't mind completing these problems on your own, and the next time I see you, we will discuss them. Let's go ahead and move on to the next set of examples. What we're going to do for these problems is we're going to add like radicals. So when it comes to adding like radicals, a radical expression with the same index, now remember that just means the same root, and radicand, so same root and radicand. Remember that radicand is the expression under the radical. So a radical expression with the same root and the same expression under the radicals, that's called like radicals. And the only way for us to add or subtract radicals is if they are alike. So radicals can be added or subtracted if the index and the radicand are like, if they are the same. So let's go ahead and look at example number 2. In example number 2, letter A, we want to add or subtract the expression and we want to write it in simplified radical form. Once again, we don't want to use a calculator. And what I see here is that I have 7 cube roots of 12 minus 1 cube root of 12. And because these are like radicals, we're combining the roots of cube roots of 12, and that's going to be equal to 6 cube roots of 12. Now, 12 does have a perfect square factor of 4, but that is a perfect square, not a perfect cube, so we can't do anything about it. We just leave our answer like this. If it helps when it comes to combining radicals, I want you to think about this problem like if I asked you to combine 7x minus 1x, that would equal 6x. That's how we are combining. It's like terms in a way. Let's go ahead and look at letter B. In letter B, 81 and 24 are not the same radical. So I have to simplify each radical individually, and then I will be able to combine them. So what I'm going to do is I'm going to look for perfect cube factors. So what I know about 81 is actually 27 times 3. And I'm going to simplify each piece individually. This is 27 times 3. Well, 27, the cube root of 27, that is equal to 3. So this is 3 cube roots of 3 minus my perfect cube factor that can go into 24, that's 8. So this is 8 times 3. And I know that the cube root of 8 is 2. So this is 2 cube roots of 3. So now if you guys notice, we now have the cube root of 3 in both of our expressions. And because we have the cube root of 3 in both of our expressions, I can now combine them. 3 minus 2 is simply 1 cube root of 3. So you can write your answer as cube root of 3 or 1 cube root of 3. Both ways are perfectly acceptable. Let's go ahead and look at letter C. Letter C, I have 4 times 2 to the 2/3 power plus 8 times 2 to the 2/3 power. And so because this is the same radical of 2 to the 2/3, and technically they're like radicals, I simply combine, and this is going to be equal to 12 times 2 to the 2/3 power. I don't do anything else with it. I don't have to deal with rewriting it in radical form. Whatever the structure is to start, that's the way that we end the problem. And this is simply our answer. There is a solo and a pair question, and I would like you guys to please go ahead and try those and be ready to discuss them for the next time that I see you. And that is the end of today's lesson. If you have any questions over anything that I talked about in this lesson, please feel free to email me. Otherwise, I hope you have a wonderful day.